So here's a video that will show you how to solve systems of linear equations. So before that, let's first talk about what is linear equations and what is not linear equation. So here we have an example: x plus y is equal to 5, 2x minus 6 is equal to 9, and then x squared plus 2x plus 1 is equal to 0. Which among these are linear and not linear? So it turns out that this first example is a linear because the degree of its variable is just 1. So that's x to the 1 and y to the 1. And whenever you have an equation that its highest degree is 1, you will definitely tell that that equation is a linear equation. And in terms of its graph, if you graph this equation here, it will definitely give you a line. So that's what linear is. And then the second example, what about this one? 2x minus 6 is equal to 9. Is that linear or not? Of course, it is linear because as you can see, the highest degree of exponent on its variable, so the variable is x and its degree, as you can see, the highest degree is 1. And all of these terms are just constants. So that's also a linear. Then for the third one, as you can see, this is the variable, this is the variable, and constants. But on the x side, you can see that the highest degree is 2. And it turns out that this is no longer a linear. So that's not linear. Why? Because the highest degree is 2. And whenever you have an equation that its highest degree is 2, that will be quadratic. Or if you graph that, it will be a curve or sometimes a parabola if it is x squared or a squared or any variable you use and the highest degree is 2. And then if the degree is 3, cubic, and so on, the degree is 4, 5, 6, and higher. So that what basically linear equations are. So to solve systems of linear equations, so now we'll be talking about systems. So these are bunch of equations involving linear. So it could be 2 variables, 3, or more. So let's say we have simple example like 2x plus y is equal to 10. And then x minus y is equal to 5. In this setup, we have 2 variables which are x and y. And we have also 2 equations. So therefore, this system of equations are solvable. So the question is how to solve. So to solve this one, we have, I think, 3 options. You could do substitution. So option 1. Option 1 would be the substitution method. Option 2 would be the elimination method, or sometimes they call it Gaussian elimination. And option 3 is the Kramer's rule, or the use of matrices to solve for the unknown values. For 3 equations, 3 unknowns, it would be 3 by 3 matrix. For 2 unknowns, it would be, or 2 variables, it would be 2 by 2 matrix. So let's try option 1 on how to solve this system of equation. Let's try option 1. So for option 1, substitution, what we're gonna do is just isolate one variable and substitute to the other equation. So in there, up here, I can isolate x or y. By means of isolating, it means leaving alone one variable to the other side and transposing the other terms or constant to the other side. So for example, if I want to isolate y, I could just subtract negative 2x on both sides or add negative 2x on both sides, and then I can now isolate for y. Or if I want to isolate x, I can move y and divide both sides by 2. Either of that will work, and then substitute it to the other equation. Or I can start here on this equation and then substitute it to the other equation. So just to give you the overview of that, let's say I want to isolate y. So my equation becomes 10 minus 2x. Hope you follow. You can follow. I just subtract 2x here on both sides. So with that, the 2x transfers to the other side. Or by means of transposing it, if you let a term passes by the equal sign or move to the other side, the sign changes. So that's why it's y equals 10 minus 2x. Hope you see it. Here's 2x and I move it to the other side. And now I have isolated y. And since y is equal to this value, 10 minus 2x, I can substitute that to the second equation, which in turns give me this one. 10 minus 2x. 10 minus 2x. That's equal to the constant 5. So originally this is y, right? So x minus y. So my y is 10 minus 2x. So I can substitute that to here. Alright? So this is the equation 1 we had. This is the equation 2. So all we did is just isolate variable from equation 1 and then substitute to equation 2. So here we have this. And then solve for the variable. So as you can see, we only have one variable unknown. So the x. So by solving that, simplifying, we'll then have x minus 10 plus 2x. I distribute the sign. So technically, this would be negative 1 times this value. So minus 10 plus 2x, which is equal to 5. And then combining like terms, it's like here, 2x and x will give me 3x minus 10, which is equal to 5. And then transposing 10 to the other side will give me 5 plus 10. And here 3x. So 3x is equal to 15. And thus, we divide both sides by 3. Will give us 5. Because 5 times 3 is equal to 15. So now that I have 5, I can substitute again 5 to any of this equation. It could be here in 1 or here in 2. Anywhere will give me the answer for y. So since y is already isolated here, I can substitute 5 here. So if I do that, y is equal to 10 minus 2 times 5. So this will give me my y. Y is equal to 10 minus 10 is just 0. So y therefore should be 0 so that it will satisfy the equation. So with that, we've just solved for x and y. And all that means is that if we graph that two lines, let's say these are the lines, the equation 1 and these are the equation 2. Say this is equation 2. Where this those two lines intersects are the points x and y. So that's the meaning of x and y. The point of intersection. X and y values are the point of intersection of this equation in terms of its graph. So in here, it's clear that the graph of the first equation, which is 2x plus y equals 10, or the red one, and the graph of x minus y equals 5, the second equation, they meet at 5, 0. And that's the solution for x and y, the coordinates of the equation. X is 5 and y is equal to 0. So that's how you do substitution. And then the next option would be the elimination. So how will you do the elimination? So let me write first the equation 2x plus y and x minus y is equal to 5. So to do the elimination method, you just have to multiply the either of the equation with a constant and then combine the equation to eliminate one variable. And since here, this y value, the coefficient of y is already you can already cancel that out because it has 1 and negative 1, and if you combine it will become 0. You will no longer have to multiply the equations with a constant. So in here, you can directly add the two equations. So this is the method of elimination. So with that, I have eliminated this y because positive y minus y or positive y plus negative y is 0y. So with that, 2x plus x is equal to 3x. And then adding this 10 and 5 give me 15. So you see, this is a lot time saver and shorter compared to substitution. So as you can see, it's the same. X equals 5 and a lot shorter and time saver compared to substitution. But still, it depends on you on where you're going to, what are you going to use. That's why it's called an option. You can use substitution and or elimination or Kramer's rule if you want. So now that we have this x plus 5, we can substitute this to any of these equations above to solve for y. So let's say I use this x minus y equals 5. And since I want the value of y, I can transpose this 5 to the other side, so it will become x minus 5, and then this y to the other side, so it will become positive y. Then substituting value of x, which is 5, this one, x is equal to 5 minus 5, and that's y. Thus y is equal to 0. So we've got the answer, the same. So that's the method of substitution and this elimination, wherein you will eliminate one variable and then solve for the other. And after solving for the other, you can do elimination again or just use substitution to solve for the other variable. And so now, let's try another example. So a while ago, that example is about two equations and two unknowns. Those were just finding for x and y, or the two unknown variables given with the two equations. So in here, the example is still, they are all linear. The highest degree is 1. And then, they are 3. We have equation 1, 2x minus y plus z equals 6. Equation 2, x minus 3y minus 2z equals 13. And equation 3, 2x minus 3y minus 3z equals 16. So, here's the other variable now, the z. So, that's the third variable we want to know. Now, to solve this using elimination, the idea of multiplying a constant to one of the equation comes here. So, suppose I want to cancel out equation 1 and equation 2. I want to cancel out one variable from it. What would you want? Well, of course, the option, I could cancel out x, I can cancel out y, or z, depending on what I want. And suppose I want to cancel out z. What do I multiply to equation, and on what equation? So as you can see, if only the variable or the coefficient of z is 2, I can cancel out z variable, right? So if this is 2z and this is negative 2c, I can cancel out z and I'm left with x and y. So, what should I do? Well, to do that, or to answer your question, we should multiply equation 1 by 2. Multiply equation 1 by 2. And why is that? Because if we multiply equation 1 by 2, our concern is to give z an coefficient of 2 and combine it with negative 2c, right? So that it would cancel out. So this is what you're going to do. Multiply equation 1 by 2. And then, if we multiply 2 on equation 1, of course, all of them will get 2. Or will get multiplied by 2. And then what? We add this to equation 1. So with this, let's now solve. 2 times equation 1 is just 2 times 2x, which is 4x. And then 2 times negative y is minus 2y. And then, finally, 2z. So that's our goal. And then 6 times 2 is 12. And then, based on this direction, we will add the equation 2. So what is the equation 2? Equation 2 is just x minus 3y and then minus 2z. So that would be equal to 13. So now that we have this the same coefficient but different signs, we can now cancel out this 2z. And by adding this one, will give us 5x minus 2 and minus 3 would be minus 5y, which is equal to 25. 12 plus 13 is 25. So let's mark it as equation A. It's the result of combining equation 1 and 2. And so now, let's again create an equation or generate an equation that has only x and y. We do that by eliminating again the z. So, what equation do you want? I suggest we use equation 1 and equation 3. Because if I multiply equation 1 by 3, I can cancel out the z variable here. Z, if this is 3 and 3, we can cancel that out. So, let me write 3 times equation 1 plus equation 3. So, with this, 3 times 2 is 6x. 3 times negative y is 1 would be negative 3y. And then, remove this because that's ganiha. Times 3 to the z, that's plus 3z. Right? And then, 6 times 3. So, multiply all by 3. Multiply all by 3. Give me 18. Then, add to equation 3. So, equation 3 is just 2x minus 3y. 2x minus 3y minus 3z. So, this is equal to 16. And then, with this one, I can combine. And what we're gonna get, of course, this will cancel out. What we're gonna get is 8x minus 6y. That's equal to 18 plus 16 is 34. Because 8 plus 6, 14. And yeah, that's 34. This would be our equation B. So now what's next? If the problem asks you only for x, then eliminate y. But if the problem asks you for all the variables x, y, and z, choose for the easier to eliminate. So in here, which is easier? Eliminate 5x and 8x or 5y and 6y. I think both of them are easy by finding their LCM or least common multiple. So let's say we want to eliminate the x. All we have to do, or let's say y na lang. Y, let's eliminate y. So what are the LCM of 5 and 6? Turns out it's 30 because 5, 10, 15, 20, 25, 30. And for 6, 6, 12, 18, 24, and then plus 6 is 30. So, their least common multiple, their common is 30. And so, to get 30y on both of this equation, we just have to multiply this equation by 6 and this equation by 5. So, if we do that, let's multiply equation 1 by 6, equation A. So, 6 times equation A, and then add it to negative 5 times equation B. So, why is it negative? Because, if you notice, negative 6y and 5y and 6y have the same sign, negative. So, we want a term that has similar coefficient or the same coefficient, 30, but different signs, positive and negative, so that they will cancel out. So that's the reason we multiply negative 5. Or we could have negative 6 and positive 5. So that's it. And by doing this, 6 times equation A will give us 6 times 5 is 30x. And then 6 times negative 5 is negative 30y. And then is equal to 6 times 25 is, let's just write it, 25 times 6. And I think it is 150. Yeah, 150. And then for this one, negative 5 times 8x. This one, negative 40x. 5 times 8 is 40. And then negative 5 times negative 6 is positive 30. So 30y. That's equal to negative 5 times 34. This one. Negative 5 times 34. Let me get this. Negative 5 times 34. And then add these two equations. So now we can cancel out y. And with this, we get the value of x. Negative 30x minus 40x is negative 10x. That would be equal to 25 times 6 plus 34 minus 5. 34 times 5. 25 times 6 times 6. 25 times 6 minus, or just plus 34 times negative 5. That's the same. And so, this is negative 20 here. So if we divide both sides by negative 10, we should get x equals 2. So now, we get the value of x. And if the problem only asks for x, we're done. But, since not all problem only ask for one variable, some problems will ask the value for x, y, and z. You can either do elimination again on these equations, or just substitute this 2 to this x, or to this x. And with that, you can solve for the value of y. And if you have x and y, you can plug into any of this equation to get z. Got it? Yeah. Let's try. So, let's pick equation A. So, plugging x to equation A, we'll get 5 times 2 minus 5y equals 25. And so, 10 minus 5y is equal to 25. And then, negative 5y is equal to 25 minus 10. And that is 15. And negative 5y. So, y is equal to negative 3. Negative 3 times 5 is 15. So, we got y equals negative 3. And substituting x and y to equation either 1, 2, or 3, either of these. Let's pick equation 1. So, substituting that to equation 1. So, it will become 2 times 2. So, 2x. So, x is 2. And then, minus y is negative 3. Minus negative 3. So, this is 2x minus y. 2x minus y plus z equals 6. Plus z, this is what we're looking for, equals 6. And so, 4 plus 3 plus z equals 6. So, transposing these terms, 4 and 3, will become 6 minus 4 minus 3. And so, z is equal to 6 minus 4 is 2, minus 3 is negative 1. Or, just think of it as 6 minus 7. So, it's negative 1. So, now we get the value of x, y, and z. So, that's 2, negative 3, and negative 1 as our solution for these 3 equations and 3 unknowns. And if you try and check whether y, z, and x are correct, just put here 2. Then since y, what's y? We got negative 3 and negative 1. So 1 is negative 3. And then for z, it's negative 1. Negative 1. And check if it will be indeed equal to 6. So 2 times 2 is 4, minus negative 3 is 4 plus 3, so it's 7, minus 1 is 6. So we're right. It's indeed 2, negative 3, and negative 1. So this is it for the elimination method, and I hope you got something here. And I encourage you to please stay tuned, because on the next video, we will discuss the third method we can use to solve for unknown values, which is the Kramer's rule. Isn't it exciting? Interesting, indeed, because we will use matrices to solve for X, Y, and Z. And of course, as always, thanks for watching. Peace out.